and welcome to my YouTube channel. Today we're going to be going over right triangle trigonometry. So we're not going to go over the trig part just yet. We're going to first focus on this right triangle that I have drawn out because there's some things that we need to understand about right triangles first. So the first thing that we're going to do is take one of these angles. So I have this angle right here on this right triangle, I have this one, and then I have a 90-degree angle. Can't have a right triangle without that 90-degree angle. I'm going to choose this one right here, and I'm going to call it theta. Theta is a Greek letter in the alphabet, and oftentimes we use theta as a variable for some angle measure. So the reason I did that is because we need to have some angle to reference to actually name and label the different sides on our right triangle. So first off, we have what's called the hypotenuse. The hypotenuse is always the longest side, and it is opposite of this 90-degree angle. So this right here is our hypotenuse. So longest side on a right triangle and the one opposite of the 90-degree angle is our hypotenuse. Now the remaining two sides, the ones that are adjacent, meaning they help make up this 90-degree angle, those are called the legs. So we want to be a little more specific when we're dealing with this angle theta. They're both legs, but they're in different locations in reference to this angle. So if I'm looking from this vantage point at this angle, I have to travel this way to hit this side. This angle is not touching this side. It's opposite of this angle. So this one right here is what we call our opposite leg. Okay. And then the one that is touching your reference angle is called your adjacent leg. Okay, so now that we have that covered, we're going to go over the trig ratios. Alright, so we have three main trig functions that we're going to go over. We're first just starting with these guys, and then I'm going to show you the inverse ones. So the first one we have is sine. Now this is my biggest pet peeve. Do not ever do this. Sine, it's always sine of an angle or cosine of an angle, tangent of an angle. You need to include whatever angle that you're looking at on your right triangle or just any angle in general that you're putting into these functions to get something out. Because what these actually represent is at that angle, they equal a specific ratio of these side lengths, okay? So sine of theta, cosine of theta, and tangent of theta. We always have to put an angle in to get something out. So don't ever just put sine by itself, cosine by itself, or tangent. It's like a function or it's like an operation. Like if I have a multiplication symbol just sitting out by itself, we can't really use it. Same thing for sine. If I have just sine written there on my paper without an angle being put into it, I can't do anything with it. Okay, so sine of theta is equal to the ratio of the opposite side. Let me make sure my coloring is right. So opposite side over my hypotenuse. Okay. Sine of theta is equal to the opposite leg over the hypotenuse. So it's the length of the opposite leg over the length of the hypotenuse. Cosine of theta is equal to the adjacent leg over the hypotenuse. And finally, tangent of theta is equal to the opposite over the adjacent. And one thing that really helps my students remember this is this little saying. Some math teachers hate this, but SOHCAHTOA, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and your tangent is opposite over adjacent. Just a little acronym to kind of help you remember those trig ratios. So up next, we're going to actually talk about these trig ratios, but their reciprocals. And then reciprocal, just vocabulary-wise, is when you have some fraction, a over b, okay, and the reciprocal of a over b is when we just flip the numerator with the denominator to get b over a. All the color changing. B over a. So that is how we get a reciprocal. So reciprocal trig is just taking these ratios and switching the numerator and the denominator. So what I'm going to do is erase this real quick. I'm actually just going to erase this triangle. Okay, so that I have some room to put these reciprocal ratios. I'm going to add these arrows here. Okay, so the reciprocal of sine of theta is cosecant of theta. So these are reciprocal. Okay, and instead of opposite over hypotenuse, we're now doing hypotenuse. I'm going to abbreviate over opposite. Okay. The reciprocal trig function of cosine is called secant, or SEC, of theta. So instead of adjacent over hypotenuse, it's going to be hypotenuse over adjacent. And finally, the reciprocal of tangent is cotangent. And instead of opposite over adjacent, it's going to be adjacent over opposite. Notice it's the same angle, right? It's just a different ratio on that same right triangle. So now we're going to do an example. All right, so the example that we are going to go over is this right triangle that we're given. We're given a couple of side lengths, and we're going to be asked to find all of these trig ratios. So for this angle, I need to find sine, cosine, tangent, cosecant, secant, and cotangent. Now, the first thing I do, especially if you're kind of reviewing this, getting back into it, or just learning it for the first time, it's a good idea to label your opposite, adjacent, and hypotenuse on your triangle. So I'm looking at this angle theta. My opposite is this side length that gives me a length of 3. Okay. My adjacent is the other leg that touches my angle, so this is my adjacent. And finally, my hypotenuse is the one opposite of that 90-degree angle, also my longest side, so this guy is my hypotenuse. Now, we're running into a slight problem here because I have a length of 3 for this opposite side, a length of 6 for the hypotenuse, but I don't know how long my adjacent leg is. So we're going to have to use the Pythagorean theorem to figure that out. So the Pythagorean theorem is a squared plus b squared equals c squared. I actually tell my students not to memorize it that way because we want to make sure that A and B are your two legs on the right triangle, and your C is the length of your hypotenuse. So really it should be leg 1 squared plus leg 2 squared equals hypotenuse squared. So our A, it doesn't matter which leg you choose. I'll just say my A is 3, so I'm going to plug that in. So 3 squared plus B squared, I don't know this other leg, equals 6 squared. 3 squared is 9. Plus B squared equals 36, okay? I'm going to subtract 9 from both sides. B squared equals, let's see, so 36 minus 9, I like to do minus 10 plus 1. Minus 10 is 26, plus 1 is 27. So B squared equals 27. You have to take the square root of both sides. Now normally B would be equal to the plus or minus the square root of 27. However, we're not going to use plus or minus because the length for a leg of a triangle can't be negative. So then we have B equals the square root of 27. Okay. Now I can simplify this a little bit. I know that 27 is equal to 9 times 3. Okay. So I have a rule where the square root of two things being multiplied is the same as the square root of one times the square root of the other one. So B equals square root of 9 is 3, so it's going to be 3 root 3. Okay, so the length of my adjacent side is 3 root 3. So now I can actually find all of my trig ratios. Just to kind of clean this up a little bit and give myself a little bit of room, I'm going to erase the work that I did for Pythagorean theorem. If you really want to see this, you can always pause the video back when I did that. And I messed up my E. Okay, so now, sine. Well, let's write this out. So katoa. Some math teachers are not going to be happy that I'm using it, but I don't mind if you use it just to help you remember. So sine of this angle, our reference angle, is opposite O over hypotenuse, which is 6. So this is 3 over 6, which actually reduces to a half. Okay. Cosine of theta is our adjacent over our hypotenuse, right? So 3 root 3 over 6, which simplifies to root 3 over 2. Okay. Tangent of theta is our opposite over adjacent. So opposite is 3, adjacent is 3 root 3. 3 over 3 is just 1, so we have 1 over root 3. Okay. Now, all I have to do is, to find cosecant, is take the reciprocal of what I got for sine. So 1/2 the reciprocal, if I switch those, is 2 over 1, which is really just 2. If I switch these, this root 3 over 2, if I flip them to get the reciprocal, I get 2 over root 3. If I switch 1 over root 3, if I flip it to get the reciprocal, I get root 3. So I was kind of nice and I did put the reciprocal function next to the original, right? But I could be a little tricky, or your teacher could be a little tricky on a test and not line them up perfectly. So make sure that you just know that sine and cosecant are reciprocal of one another, cosine and secant are reciprocal of one another, tangent and cotangent are reciprocal of one another. And that is all for today.